Okay, pre-calc. So today is our first block day in quotations. So this can be a little bit longer of a lesson, as you're not going to have a lesson, that day that you usually wouldn't have me in school. So today's lesson is going to be about simplifying trigonomic expressions. So the last 2 days we were evaluating trig functions. So we were using information and using our trig identities in order to figure out missing parts. What we're going to do now is we're going to simplify trig expressions using our identities. And what that means is we're going to go ahead and we're going to try and rewrite a more complicated expression in one of two ways. We either want to end up with just a number, so we want to end up with just a single number, 2, 3, 1, whatever, right? Or a single trig function. That's our goal when it comes to simplifying trigonomic expressions. And so there's going to be a lot of trial and error. So I highly suggest getting some scrap paper. Okay, sometimes you'll nail it on the first time. That always feels great. Other times you're going to have to try a few different things before you get it. So we have some strategies that we use in order to simplify trig expressions, and they are listed on the left-hand side here. Okay, so number one, you want to try and rewrite using reciprocal and quotient identities. Okay? Number two, look for Pythagorean identities or a possible way to create one. Okay? Number three, combine fractions using a common denominator. Number four, break fractions apart. And number five, use factoring. So you really have to get creative here when you're doing these. Okay? So please make sure to not give up after trying just once. That is very seldom occurs, that you can just find it out on your first try. So I highly suggest going ahead and taking your trig identities sheet. Hopefully you printed this out or you have it available as a tab in your computer. Remember, you can find it in the student notes. It's the very first page, or sorry, student packet. Right? And having this available will make things a lot easier for you. Right? So let's go ahead and jump into this. Remember, our goal for simplifying is to simplify down to either a single numerical expression or a single trig function. Okay? So we're going to start off with number one, where we have the secant minus sine times tangent. So secant minus sine times tangent. So I'm going to try strategy one to start off, which is rewrite using reciprocal and quotient identities. If we take a quick look at our reciprocal and quotient identities, right, that's all these guys and these guys right here, right? So it's just saying, hey, if you see like a cosecant, write it as 1 over sine. If you see a secant, write it as 1 over cosine. And then with tangent and cotangent, you can rewrite those guys a little different as well. And so I'm going to go ahead and rewrite secant as 1 over cosine. That was using the reciprocal identity. I'm actually going to leave sine. Right? Another kind of rule of thumb is try and work with sine and cosine. There's a lot more identities that involve sine and cosine than there are that involve our reciprocal function. So I'm going to leave sine and cosine if I see it. Tangent, I can rewrite as sine over cosine, right? That's the quotient identity to get that right there. Okay? And lucky for us, it looks like we actually have a common denominator. So we can take these two fractions, put them together. I can also take sine times sine, and just like having x times x gives you x squared, sine times sine just gives you sine squared. So we're going to have 1 minus sine squared over cosine. Okay, so I just combine those guys into a single fraction. And that's a good step. If we can get terms that are separated by addition subtraction into a single term, that's definitely seems like we might be headed in the right direction. Okay, so the next thing I'm going to do, that 1 minus sine squared, that looks a lot like a Pythagorean identity. Anytime we see a squared, you should be checking to see if your Pythagorean identity works out. So our Pythagorean identities that has sine in it is sine squared plus cosine squared equals 1. You'll notice we don't have anything that is 1 minus sine squared. But the cool thing about these identities is we can actually rearrange them however we'd like, as long as we just use the same tools we used to rearrange equations in the past. So for example, this is just some side work here. Sine squared plus cosine squared equals 1 is our Pythagorean identity. If I wanted to get one side of my equation to look like this, all I would have to do is subtract sine squared on both sides, right? And I would get cosine squared is equal to 1 minus sine squared. So what that tells me is that 1 minus sine squared is equal to cosine squared. So this guy right here is actually the same exact thing as cosine squared. So I'm able to rewrite it like that. And then finally, right, cosine squared over cosine, think about if we just had x squared over x. That simplifies down to just x. So this simplifies down to just cosine of theta. And we've achieved our goal, which remember was to get either a single numerical expression or a single trig function, which we got a single trig function there. Right, so you'll notice for most of these, I'll get them on my first try, but that's because I have a lot of experience doing this. But you might try something else, you might mess up, and then just try again and use a different strategy on that next one. Okay, so let's check out another guy here. So let's have you guys actually try number 2 because it's pretty similar. Right? And remember that little trick that sine and cosine, they're kind of like what we want. If we have a sine and a cosine, yeah, that's a good thing. Don't use the reciprocal identity on those guys yet. Okay, so pause, and once you unpause, I'm going to complete it. So with this one, like I said, I'm going to keep sine and cosine, but I'm going to rewrite tangent using my quotient identity. And then you'll notice I can go ahead and I can cancel out those cosines. I have one on the numerator, one on the denominator. So I just have sine of A plus sine of A left over. These guys are like terms, and just like if we had x plus x, we get 2x. If we add sine of A and sine of A, we just get 2 sine of A, and there's a single trig expression for us. So that one's all good. Hey, other times, we might have a situation like number 3. We have a few different options here. Okay, so I got cotangent squared of u minus cosecant squared of u. First, I'm going to go ahead and use my reciprocal and quotient identities. Even though these guys have squares, we can still use those identities. Okay, but we just have to be careful and make sure that when we rewrite them, we have squares in those expressions as well. For example, cotangent using the quotient identity is cosine over sine. Okay, and then cosecant using our quotient identity is 1 over sine squared. Okay. So we kind of got lucky here, and you'll notice that both these guys have the same denominator, so we can actually combine them into a single fraction, just like that. And then up top, that looks a lot like our Pythagorean identity. And just do some simple work in your head here. Right? Remember, our Pythagorean identity that involves cosine is sine squared plus cosine squared equals 1. Right? If I do 2 things here, I can get cosine squared minus 1. If I just subtract 1 on either side, okay, and also subtract sine squared, I'll have cosine squared minus 1 equals negative sine squared. So I'm just going to do the side work, but I'm going to probably stop that in just a little bit. Okay, so what I just did, I rearranged my Pythagorean identity by subtracting 1 and also subtracting sine squared on both sides. And what that did, it gave me cosine squared minus 1 equals negative sine squared. That's a negative right there. So this expression is equal to negative sine squared. And these guys are going to cancel, and we're just going to be left with negative 1. So that's just a single numerical expression. So we're good to go. Right? For number 4, we already have a fraction. So what I would like to do is I'm going to go ahead and see if I can simplify any of these parts. I've noticed that I have sine over cosine right here, right? And sine over cosine using our quotient identity is actually equivalent to tangent. Okay? And now in a scenario like this, I can actually multiply this tangent out. The reason why I'm deciding to do that is check out what happens. Tangent times tangent is tangent squared. And then when I do tangent times cotangent, okay, so this is a rule that's always going to apply. When we multiply a trig function by its reciprocal, they cancel each other out. So that's just going to be a 1 when I do tangent times cotangent. And that applies for sine and cosecant, cosine and secant. Okay. And then what you'll notice is we don't have a single trig expression yet, but we do have a situation that looks really similar to our Pythagorean identity. Tangent squared plus 1 is equal to secant squared. So this guy is just going to be secant squared of x. Okay, so now let's check out numbers 5 and 6. Okay, so for number 5, and at any point, guys, go ahead and you can just like pause before a question if you want to give it a try and then check your work. Okay, so for number 5, I'm going to kind of go ahead and make kind of a silly mistake to start off. First off, I'm going to do 1 over, so cosecant's 1 over sine, right? And you notice how when we check this guy out, it doesn't really help us at all, right? We have 1 over sine, then we have cotangent squared over cosecant. And we're not going to be able to combine those guys with a common denominator or anything. So instead, I would approach it a different way. Another way I could get a common denominator, right, is by multiplying this side by cosecant over cosecant, right? The reason why that's going to help me is check out what I get. I'm going to get cosecant squared over cosecant minus cotangent squared over cosecant. And now I have that common denominator. So I can take these guys and combine them into a single fraction. Right? And then when I check out that cosecant squared minus cotangent squared, right, I'm thinking one of my Pythagorean identities is going to apply here. So go back to your Pythagorean identities, and I have cotangent squared plus 1 is equal to cosecant squared. So if I just go ahead and subtract cotangent squared on either side, you see how I'm going to have cosecant squared minus cotangent squared, and it's going to be equal to 1. So that tells us this expression right here is actually just equal to 1. Right, so that was just, I skipped the side work, but at this point you should be getting used to somewhat doing it in your head. Right? And then 1 over cosecant, just using our reciprocal identities, is just going to be the sine of theta. And we're all done there. Okay, for number 6, you'll notice that we have cosecant and sine up in our numerator and cosecant in our denominator. Okay, sometimes it actually works out best for us if we go ahead and we separate our numerator. Okay? So for example here, I'm just going to change these b's to x's. So we're going to have cosecant over cosecant minus sine over cosecant. Okay? And because I separated, now I can actually rethink that guy as 1. And then when I have sine divided by cosecant, right, let's think about that a little bit differently. Let's just pull this guy out as 1 over cosecant. The reason I did that is because if you think about this guy using our reciprocal identity, right, that's actually equivalent to sine, right? 1 over cosecant. So I have sine times sine here, which is sine squared. And then you can go ahead and you can use your Pythagorean identity. Remember, you're going to have to rearrange sometimes, and this is one of those scenarios where you have to do that. And once you rearrange it, right, pause and do the work if you need to, you should get cosine squared as your answer there. Okay, so hopefully you are doing all right here. We're grinding a little bit, but you guys will be all right. Okay, so let's go ahead and try just a few more. I'm going to do, let's say, like 7. We'll do 7, 9, and maybe like 12 or something like that. Right? So for number 7, we have secant over sine minus sine over cosine. So we already have fractions, so rewriting these guys would create probably a lot of confusion, because we'd have some fractions inside fractions and whatnot, and that's no fun. So instead, what I'm going to do is I'm going to get these guys to have a common denominator. Okay, so right now my denominators are sine and cosine. So what this side needs is sine. So I'm going to do sine over sine multiplied to that side. which remember that's just another way to write 1 actually, but it makes it so we can end up having a common denominator. And then this side needs cosine, so I'm going to do cosine over cosine of this side. So that's going to be cosine of u and secant of u over cosine sine. Okay, so we have the same denominator. And now what we need is to simplify these numerators a little bit before we can combine. Cosine times secant. Just like earlier, I mentioned that when we take a trig function and we multiply it to its reciprocal, it actually equals 1. Okay, so that's going to be 1 minus sine squared over cosine times sine. Right? 1 minus sine squared, that's definitely one of our Pythagorean identities there. If we rearrange sine squared plus cosine squared equals 1, if we just rearrange this guy right here, we're going to have that this is equivalent to cosine squared. And then you'll notice we'll be able to eliminate this cosine here, and we're just going to have cosine over sine, right? And cosine over sine is cotangent, right? And we're all done. Okay, so for number 9, okay, in this scenario, you'll notice we have some multiplication going on, and they're two binomials. So for the most part, when you see that multiplication, give it a try and see what it simplifies down to. So I'm going to do FOIL here. Cosecant times cosecant is cosecant squared. And then I'm going to have minus cosecant of x plus cosecant of x, and then minus 1. You'll notice those middle terms are going to cancel, and we get something like that. At this point, you're going to be tempted to cancel out those cosecant squareds, but remember, you can't do that because that minus 1 up in the numerator. But instead, we can go ahead and take a look at some of our Pythagorean identities, and that numerator looks like if we rearrange this Pythagorean identity by just subtracting 1 on each side, we'll get to a point where this guy is equal to cotangent squared. And remember, we still have more than one trig function, so we got to do more. And in this one, we don't really have any other options other than this right here. I'm going to rewrite cotangent squared as cosine squared over sine squared. And then I'm going to rewrite cosecant squared as 1 over sine squared. So I have a fraction divided by a fraction, which is a little messy, but what we can do is we can go ahead and we can do keep, change, flip. So I'm going to do cosine squared, sine squared, times sine squared. So I did keep, change, the division to multiplication, and flip that guy. And you'll notice now it gives us the ability to cancel those, and we're just left with the cosine squared of x. Okay, so number 12 is going to be our last one here. And I thank you for grinding it out with me if you're still with me here. And so another common thing that might pop up is you might be able to factor out a GCF. And on number 12, you'll notice that our numerator has sine cubed in both of the terms that are in that numerator. So what I can do is I can actually pull that sine cubed out in front, and I'm left with cosecant squared for this term and just 1 for that term. So I have a few options for what I do next. It looks like this cosecant squared of x minus 1 is definitely going to be one of my Pythagorean identities there. If I look at this guy right here and I rearrange it a little bit, cosecant squared minus 1 is actually equivalent to cotangent squared. Right. So another thing I can do is I can go ahead and I can take this sine cubed over cosine cubed, and that is going to be our quotient identity, will give us tangent cubed. Right. So at this point, we're multiplying tangent times cotangent, but we got to keep an eye on our exponents here. We have a 3 and a 2 in our exponents. So remember, our trig functions multiplied by the reciprocals end up equaling 1. They cancel each other out, but we have 3 tangents and we have 2 cotangents. So only 2 of these guys are going to cancel out, and we're still going to have a tangent left over. and that would be our simplified answer. Okay? So to practice this, I want you guys to go ahead and do the odds on homework 2. You will have a quiz on this, right? So please make sure you take some solid notes and also print out that Trig Identities reference sheet because that will be very helpful. Remember, my office hours are from 11 to 1.